Hi everyone. Today we're going to be looking at solving equations. Now we've been doing factorisation for a little while and we have things like common factor and quadratic factorisations, even difference of two squares factorisations. All of these could be useful today. So let's begin with something like this. If I have the equation x squared plus 7x plus 12 equals 0. Now the difference today is that we have this part here. We have this equals and then something else on the other side. In the past few weeks, we haven't had an equals. We've just had the left-hand side, the expression. So let's see what difference this makes. Well, we begin by factorisation. This is a quadratic. I can see that it's a monic quadratic. The term in front of the x, the coefficient is a 1 in front of the x squared term. So I need two numbers that add to 7 and multiply to 12. The numbers are positive 3 and positive 4. Now I find myself in a very interesting situation. I have a product, a multiplication, that something multiplied by some different thing equals 0. Now let's just try for a minute. If I was back in primary school and I had a question that looked like this, 5 times box equals 0, what's the missing number in the box? Well, you would, I hope, tell me that the only answer for that would be 0. 5 times nothing equals nothing. Nothing else will work. What if I had a situation like this? Unknown number times negative 10 equals 0. Again, I'm pretty sure you would tell me the answer is 0 is the only thing that would multiply by negative 10 to equal 0. Now what if I do this one? Unknown number multiplied by a different unknown number equals 0. Actually, back in primary school, if it was two squares, it meant the same number, didn't it? So what if I do triangle here? So what missing number? Well, I don't know. Perhaps the 0 belongs here and the triangle is a non-zero number. Or perhaps the 0 belongs here and the square was a non-zero number. I cannot say for sure which one of these, but I know that at least one of them must be 0. And that's what's called the Null Factor Law. This idea that when a product, when the multiplication between two terms equals 0, we only have two, well, in this case there's two terms, so there's two possibilities. It could be that the first term equals 0, or it could be that the second term equals 0. And in this case, I would have x equals negative 3, and in this case, I would have x equals negative 4. Now, both of those answers will actually satisfy the original equation. I can check that by substitution. So I'll just grab my calculator here. Now, my original equation, let's see, I think my first solution is negative 3, which was squared, plus 7 times negative 3 plus 12. That looks like my original equation with a negative 3 substituted, and it equaled 0. Now if I go back, that's the one, and change that to be a 4, it also equals 0. This equation has two different answers, both of which solve the equation. So this is how we solve equations. We typically will start with the equation equals to 0. If it's not equal to 0, we can always transpose that number to make it 0 and then slightly alter what we're doing. Then we factorise, then we apply the Null Factor Law. The main idea of today is the Null Factor Law. But you'll still need to use your factorisation techniques before the Null Factor Law can come in. Let's take a look at another example. Now, I might pick one that involves a difference of two squares this time. Let's say I had the equation 27 minus 3x squared equals 0. What a lovely equation. Now, the first thing I can see is a common factor of 3. So remember, with our factorisation techniques, always look for the common factor first. So this would be 3, 9 take x squared equals 0. Now I can see that 9 is a square number and x squared clearly is a squared number. Just to be sure, I'll write this as 3 squared minus x squared. And now the difference of two squares would become 3 plus x and 3 minus x. All the while I have equals 0, equals 0. Now I'll use my null factor law. Sometimes I just abbreviate to NFL. Now I've got a product here, don't I? I've got 3 multiplied by this term, multiplied by this term. Well, clearly the number 3 cannot equal 0, that's nonsense. But 3 plus x could equal 0, or 3 minus x could equal 0. In this case, I'll transpose to be a negative 3, and in this case, I'll leave the positive 3 where it is, and I'll transpose the x. So the x is, it's either a negative 3 or a positive 3. Once again, I could go back to my original formula with those two solutions and check them on my calculator. So my formula said 27, take 3. Now I'll put my little minus 3 solution in a bracket and square it. Equals 0, just like we thought it should. Let's go back and try the positive 3 answer. Equals 0. Of course, it worked nicely. Maths works. Now there's just one other one I thought I would try for you. What if I had, and I promise I'll be quick, what if I had something like 2x squared take 14 equals 0. Well, I can see a common factor of 2, x squared take 14 equals 0. Now this almost looks like a difference of 2 squares. If only I could have something which when squared was the same as 14. Now what could I put here that when I square it would be the same as 14? I know, I could put the, oh, did I leave it as 14? Silly, that's a 7. Because I took a common factor of 2, didn't I? That's what you get for trying to rush. Remember, working slowly is better than working quickly. So that's a 7, yes. Now, what would I need to have there? Well, square root of 7 squared is the same as 7. This is a difference of 2 squares if I use the square root. So I could have x plus the square root of 7. I could have x minus the square root of 7 equals 0. And now it's a product, so I use my null factor law. X plus root 7 equals 0, so x could be negative root 7. The other alternative is that x minus root 7 equals 0, so x equals positive root 7. And that's the null factor law. Remember, step 1, factorise. It could be common factor, it could be quadratic factorisation, or it could be difference of squares, or it could be a combination of those. Then, once factorised, once we have things which are multiplied together equal to 0, this is when the null factor law is useful. It must be a list of things multiplying together equal to 0 before we apply the null factor law. That's enough for now. Hope you enjoy your null factor law and solving equations. Thanks for watching.